Okay, so let's do a second practice problem here with parallel plate capacitors. Again, you should be doing this along in your notes so that you have it when you go to do your problem set. This one says 2 parallel plates, each 2 centimeters wide and 4 centimeters long, are stacked vertically, it should say, so that they create a uniform electric field directed upward. If the plates have a charge density of 8.85 times 10 to the negative 8 coulombs per meter squared, how much charge is on a plate? And what is the magnitude of the electric field created by the plate? So first of all, just so you understand, they're just saying that you have this situation here, right? That you have 2 parallel plates. They're 2 centimeters by 4 centimeters. And then the electric field is directed upward, so it's like this. So that means that the positive plate is down here, and the negative plate is up here. Okay, as best as I can do it. All right? So that's the situation they have, and all they want to know is the electric field and the magnitude of the charge. So let's go ahead and get started. They give us that sigma, the charge density, is 8.85 times 10 to the negative 8 coulombs per meter squared. We're dealing with parallel plate capacitors, and in this case we're going to need our epsilon naught, and epsilon naught is 8.85 times 10 to the negative 12. So this should show you some things already about the electric field, but we're going to do that carefully, and this is coulombs squared per Newton meter squared. All right, and they ask us to find the electric field, and they ask us to find the charge Q on the plates. All right. So our formula that we're going to use, well, we're going to use our formula that says E equals sigma over Q. And then we're going to also use a formula sigma equals, sorry, I did this wrong. That doesn't belong there. Let's fix that. Sigma over epsilon naught. Recall that the formula was Q over epsilon naught A. So sigma, if you recall, our charge density was the Q over a piece of that. Okay, so you saw this formula in your notes earlier. E equals Q over epsilon naught A. And this piece was the piece that made up the charge density, just to bring us back there. All right, so our work here looks like this. The first part is pretty easy. Let's just go ahead and do E. So E equals sigma, which is 8.85 times 10 to the negative 8 all over epsilon naught, 8.85 times 10 to the negative 12. So that means that our electric field is 10,000, so 1 times 10 to the 4th newtons per coulomb up. All right, that's our E field. Now let's look at Q. So Q is equal to sigma A. So Q is equal to 8.85 times 10 to the negative 8th times the area. Well, the area of a rectangle is just length times width. So times 2 times 10 to the negative 2. And I should have put that over here. So we have width is 2 times 10 to the negative 2, and height or length is 4 times 10 to the negative 2. I should have put that up there explicitly, but anyhow. And 4 times 10 to the negative 2. And so that means that Q is equal to 9 point, no, don't do that, 9.23 times 10 to the third coulombs. Okay, there's your second problem.